Proportions are nothing more than equal ratios, which are nothing more than equal, why is this doing this? Fractions. Equal ratios, equal fractions. And you have seen this before. This everybody's pretty happy with. You know, let's say if this proportion, this is proportional. 2 over 4 equals 6 over, how do you go from 2 to 6? You multiply by 3, so 4 times 3 is 12. Okay, this is a proportion, 2 equal fractions. Now the problem comes up in the fact that sometimes our proportions are not like really easy and neat. Let me see if I can find them in here. Like this one. E over 9 equals 5 over 15. E over 9 equals 5 over 15. Now, looking at this, if we do some whatever looking at this, if I were to ask you 9 times what is 15, there is something, it's a fraction, but you really don't want to do that. We don't know. If that happens, what should you try first? We've got a couple different things we can do, but we should try something first. Brenda Massey?
Reducing?
Yeah, you check to see if the fraction you do know can be reduced. And 3 or 5/15 can be reduced to what?
1/3.
Yeah, 1/3. And then check to see if that works. Can you go from 3 to 9?
Mm-hmm.
Right, you do what? Or times it by 3, and so 1 times 3 is 3. So E equals 3. Now the question we have though is this. What if I can't find something? What if I have 1 over 3 equals what number over 10? So you look at it and you go, well, I can't go from 3 to 10. Well, actually, maybe that one you could actually do better than that. It would be a fraction sort of thing. And you can't reduce 1/3. It's already reduced. So you have to do what we say, use what we call cross products. Put a double exclamation point because this is very important. Use cross products. One thing you know about equal fractions, boys and girls and ladies and gentlemen, is that if you multiply the diagonals together, what is 4 times 6? And what is 2 times 12? Let's go back to this one. What is 9 times 1? 9. What's 3 times 3? 9. One thing, when you have equal fractions, their diagonals are equal to each other. And if you know that, you can make an equation out of this, which just does that. You know that this times this, 3 times n, has to equal 10 times 1. It has to. And then once you know that, you can solve this. What do I have to do to solve that? If this says 3 times what number is 10? You know, if you don't, I guess we haven't really solved that, but you can think of an easier problem. You know, if I have 2 times 5 equals 10, what? If I'm missing this middle thing, what do I do with 10 and 2 to get 5? Huh? Divide. And that's what I'm going to do here. I'm going to take 10, divide it by 3, and I end up with 3 1/3. And again, it's not a nice number, but that's what it is. 3 1/3 is what the letter is. Everybody happy with that? I don't think they'll actually give you too many of those, but if you do need that, always check to see if you can reduce. And if that doesn't work, then it's now. I need to take out a blank piece of paper because proportions are part of our next little deal, which is ratio word problems. So under word problems, write the word ratio. These are also called proportions, but we can do it like this. And here's what it looks like. I'll give you the example word problem. The ratio of boys to girls was 3:4. If there are 12 girls, comma, how many boys? Now, whether you know the answer or not does not matter to me. This is all about the process we use to solve this. And in order to solve this, ladies and gentlemen, write in ginormous letters, you are going to use, listen, I heard it out there already. You are going to use ratio boxes. Just like eventually we'll use percent boxes, we'll do fraction boxes, it's all just kind of helps you stay organized here. And this is what those look like. You take a box, cut it into 4 pieces, and you label them accordingly. This column going down is the ratio column. You could just put the letter R, but I'll write it out for this. This is the actual. Okay, those always stay the same. What changes is these. These are the 2 things that you're comparing. What am I comparing in this problem? I am comparing, I guess I'll start with the one. It doesn't matter which one you put on top. I am comparing boys to girls. And the problem will tell me 3 of those 4 boxes, and I have to figure out the 4th one. Well, what is my ratio of boys to girls? It says right here, ratio of boys to girls was 3 boys for every 4 girls. If there are 12 girls, that's my actual. I put that here, and I am looking for this box here. Now, let me just tell you, when you do this, what you're doing is just making equal fractions. This fraction 3/4 has to equal this fraction over here. And sometimes you might have to do this off to the side, but in this one it's pretty easy because to make equal fractions I just go 4 times what is 12? 3. So 3 times 3 is 9. And there is my ratio. But I need, this is what I need to see. Whether you can do that in your head, that doesn't make so much of a difference to me. First day on that. Ready for another? Yes, there are. The teacher to student ratio is 1:20. Unless you're in Chicago, that's like 1:30. Maybe 1:40. Teacher to student ratio is 1:20. 1:20. If there are 100 students, how many teachers are there? If there are 100 students, how many teachers? And you can probably figure that out, but that don't matter. We're going to draw ourselves a ratio box. How is Mr. Ratio Box going to be labeled? This is always the ratio. This is going to be the actual. What 2 things am I comparing? Teachers to students. And what is my ratio of teachers to students? 1 teacher for every 20 students. How many actual things do I have? Do I know the teachers? Do I know the students? I know there are 100 students. And I just need to figure out how many teachers there are. So this is 20 times 5, and this is 1 times 5. So there would be 5 teachers per 100 students. How about that? Now we need to go back to proportional again because I opened the column there. Kevin, sir.
If the ratio that they give you, if it's able to be reduced.
You could if you wanted to. You don't have to, but yes, you could. Make it easier for you? Sure, you could if you wanted to. If they gave this a 6 to 8, feel free to reduce it. Go back to your proportion things there. And write this down. In your notes under proportions, to be proportional, comma, things, I don't have a better word than that. Things must have a constant factor, which we probably have to talk about a little bit here. What does a constant factor mean? Well, constant means what? Constant means the same. And factor means, what are factors? Things you multiply by. So if it's a constant factor, it must be multiplied by the same number. For example, let's say you get a job and you make, I don't know how much an hour. Wow. Where do you work in Chicago? Let's say you make $8 an hour because you're a kid. You don't deserve any more. Is your pay proportional? Okay. And here is the test for that. What you would do is make yourself a little chart, a little table, where this is the number of hours you work and this is how much pay you make. All right. If you work no hours, how much money do you make? 0. If you work 1 hour, how much money do you make? $8. If you work 3 hours, how much money do you make? 24. If you work 8 hours, you will get 64. So for this to be proportional, what has to be true is this. If I go from 0 to 0, every one of these things I need to be multiplying by the same number. Do I multiply by the same number? What am I multiplying by? My constant factor is 8. Because 0 times 8, 1 times 8, 3 times 8, 8 times 64. Now, if, let's say you have a job, and let's say this job is mowing yards or whatever, if someone pays you a flat rate of, let's say they give you $5 for showing up, and then they give you $6 per hour. So you get $5 just for showing up. If I make a table of that, let's see how that changes stuff. Well, if you work 0 hours, you're still getting nothing because you didn't show up. Now this time, if I work 1 hour, I get $5 for showing up plus $6 an hour, I get $11, right? If I work 2 hours, what's my pay going to be? $12 plus the $5 for showing up, which is 17, right? If I work 7 hours, 7 times 6 is 42, plus the 5 is 47 hours. Is this proportional? And here's the test. You have to go not to the 0 one, but to this. To go from 1 to 11, what do I multiply by? 11. For this to be proportional, every time I would have to multiply by 11. And 2 times 11 does not give me 17, nor does 17 times 11 give me 47. This is what we call not proportional, because it doesn't have a common factor. If it doesn't have a common factor, it is not proportional. Are most things proportional, yes or no? Generally speaking, yes, because we're in a society where the more work you do, the more pay you should get on a whatever basis. But if you were salaried, which means what, River? If you're salaried, what does that mean?
You get paid a certain amount.
You get the same amount of money no matter how much time you work. Let's say you make $1,000 a week. You know, if 2 people make $1,000 a week, that's not necessarily proportional, because one guy might work 40 hours, the next guy might work 60 hours, and it would not be the same factor to get there. This would be $25 an hour. This would be what? If you work 60 hours, you get $1,000. What is that? 1,000 divided by 6. What's 100 divided by 6? This is like $16 an hour. You'd have a different factor. So salary is kind of one of those things that doesn't. All right. Let's see what we're